Hello and welcome to Lesson 8. This is Software Design and Development for National 5 Computing Science, and today we're going to be looking at iteration and repetition. They kind of mean the same thing, but we're looking at making loops using fixed and conditional loops. We're only going to look at fixed loops today, so let's take a look. I've created a new REPL. It's a blank one. I called it Iteration 1 Fixed Loops. So what I'm going to do first, I'm going to write 2 lines of code and then I'll explain what it's doing. So here's how you start a loop. You write for a variable, the control variable, you say in, then your iterator, and then a colon, press enter. Now any code that is indented after the colon will be repeated. So let's print hello. Now let's explain what this does. Now you might be able to guess that what it's going to do is print the word hello 10 times. And when I run it, you'll see that's exactly what happens. But why? What do these pieces of code mean? Well, for is just the keyword that tells Python you're a way to start a fixed loop. It's called a fixed loop because it knows how many times it's going to repeat before it starts looping. In this case, 10 times. X is just a variable name, and it will contain one thing that is in the next part, which in this case is range 10. But what is range 10? Well, a range is just a series of numbers. How many numbers? This many. So 10 numbers. This range contains 10 numbers, but ranges start from 0. So that's 0 to 9, 10 numbers. Now we can prove this. As I said, X is just a variable that contains one of the things that is in this range. So for X in range means repeat this many times, and each time round the loop, X will contain one of the things inside this range. In this example, we can check this by typing print X. 0 to 9, as I said. So the first time round the loop, X contained 0, and we printed that. Second time round it contained 1, and so on and so forth until we got to the last one. So that's what this does, and you can do this for any number, 3 or 3000. And you can see, you can see that Python is very fast and will print that almost instantly. See how fast that was. Because this results window isn't big enough to show 3000 lines, it stops. It's just over 1000 lines it can show. But I'm going to clear this for now. Bloop. So this is probably the most simple fixed loop that you can make for X in range 10 and then what you want to do 10 times. Again, you can change the number of loops there. And this variable name, it doesn't matter what it is. A lot of people use I instead, which a lot of the time stands for index or iterations. It doesn't matter what you call it as long as it adheres to the usual variable naming conventions. So I could call it whatever I wanted. Look at this. Here's a variable name. I'm going to print that and run it. And you can do things with this variable in any way you would with other variables. If I wanted to double this variable, so instead of X, I'm going to print X times 2. So it's going to be the 2 times table all the way up to 18. Look at that. Or I could square it. Let's square it. So here are the square numbers. Woo! Not bad, right? Let's say, for example, I wanted to show the 10 times table up to 10 times 10. Well, let's change this. Instead of times 2, this is going to be times 10. But as you'll know, when we're reciting the 10 times table, we don't normally say 10 times 0 is 0. And you wouldn't stop at 90, you would go all the way up to 10. So how do we change this? Well, we could change this to 11, and that'll make us go all the way to 10, 0 to 10. But that doesn't solve the problem of starting from 0. So we're going up to 100, but we're not starting from 1, we're still starting from 0. There are 2 ways we could fix this. I think the simplest way is instead of going up to 11, just go up to 10. And instead of multiplying x by 10, multiply x plus 1 by 10. But watch this, watch what happens here. We've got some odd numbers. What's this? We've got 10, 11, 12. This is not the 10 times table. So what's happened? Well, if you know anything about maths, you might have heard of BODMAS or BOMDAS or PEMDAS. So different teachers tell you different things. But it's basically the order of operations. I always do BODMAS, brackets, orders, division, multiply, add, subtract. So what this is doing is it's multiplying. So we're doing 1 times 10 plus x. So 1 times 10 is always going to be 10. And all we're doing is we're adding 0 the first time round, then 1, then 2, and so on. So that's what this is. How do we fix this? Brackets. Beautiful. Let's run it, see if it fixed it. Yes. 10, 20, 30, 40, 50, 60, all the way to 100. Beautiful. That's a beast program. So this is one way we could fix that problem. Another way, which doesn't involve doing this fancy stuff and having to know about BODMAS. Let's do x times 10. But this time, I'm going to give this range two numbers. Two numbers! I'm going to give it a start and an end. It's going to start from 1, and it's going to go up to 11, but it always stops 1 before the second number. So this is going to give me the same result. So this range now starts at 1, and it ends 1 before 11. It's very similar to the previous example, where we stopped 1 before the number we typed in. Now, just to give you the full picture, we can actually add 3 numbers to this. We could tell it the third number, and this is how many steps it will take. So by default, it will take 1 step at a time. But if we tell it to go 2 steps at a time, it's going to be the 10 times table, but it's going to go up in 2s. So we're going to start at 1, then 3, then 5, then 7, then 9 times 10. This is easier to see when we give it a bigger number. There we are, going up in 2s. And it's even easier to see if we start at 0. There we go. 0 to 98. Because it always stops 1 before this, but 99 wasn't an option. So this is a range, and x will contain a number within this range. Ranges can have a single number if you just want to start from 0 and end 1 before this number, going up in 1s. We can give it 2 numbers, a start and a stop, but remember it stops 1 before the number that you type in for the second portion. There we are, same deal. Or we can give it 3 numbers where the third number is how many steps it will take. So I can make it go all the way from 0 to 1000, but going up in 5s. There we are. Not bad, right? But let's say before we run the program, we don't know how many times we want it to loop. All we know is that we're letting the user choose. So let's let the user type in a whole number from the keyboard, enter a number. And we're going to loop num times. Num. Now watch what happens. It asks us for a number. If I type in 15, it loops 15 times. But again, starting from 0, finishing 1 less than the number entered. Let's say I wanted it to start from 1. What could I do? I could tell it to start from 1. But if I wanted it to go up to the number that I type in, for example 15, watch what happens. 15. It stops 1 before it. Why is that? Because it always stops 1 before it. So if I wanted to go all the way up to the number that I type in, what can I do? Well, instead of stopping 1 before it, I could just add 1 to it, and then it will go right up to the number. Beautiful. Okay, that is a quick introduction to loops. You probably don't have much of an idea of why you would use a loop, but we're going to take a look at that in the next lesson.